Let's now see how we can create a polymorphic collection of polygons by using polymorphic method parameters for mutated method. This will be very similar to the way we discussed about the student management system, where we simply got a polymorphic collection of students. So there's nothing conceptually new over here, but it will be very beneficial for us to go over the whole idea again, just to reinforce your understanding. Okay, just be patient so we can walk it through. Okay, so let's say we got a class called Polygon Collector, right? Analogous to student management system, which collects students' objects. Let's say we got a polymorphic collection over here, Polygon. You can see we choose the type to be as general as possible in the inheritance hierarchy. Think about, what about alternatively, we simply got, let's say, rectangle over here as a static type for the array. In that case, we are restricting ourselves to the descendant classes of rectangle, which will be just rectangle. But now if we chose polygon over here, we are giving us the possibility of either polygon itself, actually not polygon itself, because remember, abstract class cannot be dynamic types at the runtime. Okay, so here being polygon being the static type for every element in the array, what can be the dynamic type for each member, each element in the array? It can be either rectangle or triangle. Hopefully that makes sense to you. Okay, so polygons here is really a polymorphic array whose member can either be dynamically rectangle or triangle. And we got an auxiliary counter to keep track. And we got Polygon Collector constructor, and then we simply initialize a polygon array of size 10, let's say. And we also have a way to add polygon. You can see here the method parameter itself is polymorphic, meaning that when we want to pass the actual arguments for this method call, in that case, because the call by value, which I'm going to review very quickly. So the argument, the static type for the arguments can be any of the descendant classes of polygon. In this case, either rectangle or triangle. Hopefully you're still following me. Otherwise, you may have some shaky foundation from the earlier lecture about inheritance. So you may want to review them or just get in touch with me, right? Okay, so that's a very conceivable implementation that we have been doing so many times. And also grow all. So here you can see we just go over the array of polygons over here, and then we'll simply call grow. Okay, so there are two things for us to think about, which I will illustrate as well. Number one is this a valid call on the grow based on the static type for the polygons array member at index I? Number one. Number two, which version of the grow method will be called? All right, so these are the two questions you can think about before you actually before I get to them. Let's now go over some bullet points, and then we'll switch on to iPad to do some visual illustration. So polymorphism, you want to look at line number 5 over here. It's indeed polymorphism for the method, right? So dynamically, when we actually want to call this method, the arguments can be any type that's a descendant class of polygon, right? That's something we said about before. Dynamic binding is for line number 10. Dynamically, we know that polygons at index I may be pointing to either a rectangle or a triangle objects. In that case, the grow over here is going to call the version corresponding to the dynamic type, which we'll see. All right, so hopefully you're okay with what we are talking about so far. And the grow all over here is analogous to the register all method that we did earlier in the student management system. All right, so you can see whenever we got polymorphic collection, the tasks that we want to perform on the polymorphic collection is very similar between examples. That's also one of the main points I want to carry through to you. Let's now do some visual, shall we? Okay, so we got our polygon class over here. Just remember the get area is actually deferred for its implementation, right? Just remember. Okay, that's abstract over here. So that's why the class is also abstract over here. And we got two concrete classes. Well, the opposite to abstract is simply concrete. So that's something I might use sometimes. So we got rectangle being concrete, and also triangle also being concrete, right? Because it got this inherited abstract method get area implemented using different formulas, right? We got our Polygon Collector over here, right? That's something we spoke about just in the slides. And I want to draw your special attention to two parts. Number one is about here. Add polygon, and the parameter over here is simply polygon. And we'll speak about it in just a moment. And also we got this line over here, polygons at index I that grow, right? We're going to answer the question which I posed to you earlier. And that's some partial visualization which will save us some time of drawing, but I would encourage you to really draw from scratch if you can afford the time, and also practice yourself. Let's now talk about this fragment of code, example code. You can also find it later in the slides, but let me just go just in time about the illustration. Okay, so we got Polygon Collector, code maybe, and also new Polygon Collector, right? So this is the object we're creating, and remember, it's going to have 10 different polygons maximum, right? Initially, the number of polygons would just be 0 initially, right? Let's now try to look at these two lines. Okay, number one, let's look at this line over here. You know what? Let me just number one. Why don't I use green? Okay, over here. That's number one over here. Should this compile? Okay, so you should look at. You can see it's an anonymous object over here, but you can see anonymous object of type rectangle. Can I pass rectangle where I am expecting polygon? Right, according to call by value, right? So that's something I would like you to see very carefully. Okay, so this part over here is really important to actually understand for call by value, right? So this part here is going to be call by value. So call by value is going to be P declared statically as polygon is really assigned to whatever the argument is, right? In this case, new rectangle. What we know very well from the early example, this one should be okay, right? Should be valid. Because you can see this particular substitution here, should it be valid? It should be, because rectangle is a descending class of the static type of P, which is polygon. Of course, rectangle can fulfill the expectation for polygon. You can see rectangle is a subclass of polygon. Okay, so this is valid. It's valid, so I'm going to say check. Okay, and similar, well, of course, if you execute this, you're actually going to add this object into the Polygon Collector. So let's now, so this rectangle is going to be 3 and 4. So we got 3, 4, 3, 4. And by executing add polygon, we're just executing the programming pattern that we have been familiar with. So what's going to happen is, index 0 over here is going to point to wherever, index 0 is going to point to wherever this triangle, this rectangle, beg your pardon. Index 0 is going to point to wherever this rectangle object is pointing to, okay? And then we're going to increment the NOP, number of polygons, to be 1. All right, so far so good. And I will leave it more like an exercise for you. Should this line be compilable? Should it be valid? Well, of course, what you should do is you should really do the same for about call by value. So call by value is going to make sure when you assign this to the parameter P, it should still be valid. But why? You will have a very similar argument as this one here. Right? I'll leave that as an exercise for you. Very important. All right, so for this one here, we got rectangle. Oh, sorry, keep saying that wrong. We got a triangle over here, right? 3, 4, and 5. So 3, 4, and 5, and we're going to add this triangle into the Polygon Collector. Index 1 is going to point to this array. It's going to point to this triangle object here, right? And NOP will be incremented from 1 to 2, right? So far, so good. Okay, let's now try to do a little bit more. Okay. Let's now try to do, let's say here, if I say code the polygons at index 0 that get parameter, right? And versus code the polygons at index 1 that get parameter. Okay, let's see how to answer these two questions. Okay, if you take a look at the context object over here, like here, the context objects, we already see polymorphic collection because you can see the static type for every element. Again, let's now look at this. So you can see at every index of the array, the member was declared to be a polygon array over here, right? So static type for every element in the array is actually polygon. But what about dynamic type? You can see the dynamic type right now. One is rectangle at index 0. The other one is triangle at index 1. These are the dynamic types. They are different, right? So you can see rectangle over here and also triangle. So these are the dynamic type. That's actually different, but they're still descending classes of the expected static type. Okay. All right. So now we just want to see, for example, let's say polygons at index 0 is pointing to the rectangle objects over here, right? So that means dynamic type over here. Dynamic type is rectangle. And what about polygons at index 1? Index 1 is actually pointing to, right, this object here. So dynamic type should be triangle. So this part over here, let me just write better. So this part over here, dynamic type should be triangle. So just say triangle. Right? So now in this case, if the dynamic type is rectangle, when you say get parameter, it's going to invoke the version of get parameter in rectangle. Right now in this case, as we said before, there's only one version of the get parameter in the Polygon class. It's not overridden in either rectangle or triangle. So that's why there's only one version. Okay, so that means in both cases, let's now see. In both cases, it's going to be the version from Polygon. There's only a one and only version. So version of Polygon. Okay, it's very important. And let's now try to trace one more line of code over here. Let's say we try to do code.growAll over here, right? So that means we are invoking this method here. So code is the Polygon Collector and growAll. So we are executing this method here, right? And for every iteration, we're going to invoke depending on what the index I, the loop counter I is. So this I is going to be 0 and 1, right? Since we only got two, indices of the array, that's actually assigned to non-null objects. So only 2 iterations, right? You can see number of polygons. Well, here it's just NOP for short. So that's only 2. So that means I is going to be 0 and 1 in the loop. In the case of I is actually equal to 0, so what we're doing is we're doing polygons at index 0 dot grow. In the case where I is equal to 1, so we're doing polygons at index 1 dot grow. Right? So now if you take a look, we are actually invoking the same method grow over here, right? And by the way, there's only one version of the grow, if you see, right? This is the version. That's the only version of grow in Polygon that's actually available, because this will be simply inherited verbatim to here, rectangle, and also inherited here, the triangle, without being overridden. So only one version, first of all. But I still want to see the context object just to be sure. So it's going to be the version in Polygon. Okay, and the next example I'm going to see, we'll see different versions between the 2 subclasses. We'll see. But for now, let's concentrate on what we have. So you can see polygons at index 0 over here, right? At index 0 is actually pointing to rectangle, right? In this case, dynamic type is actually rectangle. Okay, so dynamic type is actually rectangle, right? But it's still going to call just a single version that's actually inherited to the rectangle. So this will be inherited to over here. And similarly, if we talk about second iteration, polygons at index 1. Index 1 is pointing to this object of dynamic type triangle, right? So the dynamic type for second iteration will be triangle. However, it is still going to call the same version of grow. Basically, it is the grow that's actually inherited verbatim to the triangle over here, also inherited. Okay, even though it's calling the same version, but it's still important for you to figure out the reasoning, like what I just explained. Okay, so that's about very quick review, and also tracing about polymorphic collection. The way to make it happen is by having polymorphic method parameter, and you have to know how the call by value actually work behind the scene. That's really important for you to review. If you got any doubts, you should really refer to the earlier lecture about the student management system example for method parameters and polymorphism, or reach out to me. All right, let's now move on to the next example, which will be about how we can get polymorphic constructor for returning polymorphic values.